Derive equations of motion using velocity time graph, or derive v square equal to u square plus 2as using velocity time graph. Consider a body moving with uniform acceleration a. Let u be the initial velocity, v be the velocity at time t. Now let us draw velocity time graph. Okay. Y-axis, x-axis, time, AB is the Vt curve, OA is the initial velocity u, let this be time t. So velocity at time t is v. This is reference line. O, A, B, this is C, this is D. AO is initial velocity. Then DC is also initial velocity u, DC. Therefore BD is change in velocity. BD is v minus u, change in velocity. To derive v equal to u plus at. Slope of velocity time curve gives acceleration. Therefore A equal to slope of AB. Slope of AB is BD by AD. Slope is tangent of this angle. Okay. So tan theta in this right angle triangle ABD is BD by AD. It is BD by AD equal to BD is change in velocity v minus u. V minus u by AD is OC. OC is T. Rearranging, AT equal to v minus u or v equal to u plus AT. In vector form, v equal to u plus AT. These are the vectors: velocity, initial velocity, acceleration. To derive S equal to ut plus half at square. Area under velocity time graph gives displacement. Okay. So area of OABC. So it is a trapezium. We want area of this. Area under velocity time graph represents displacement. Therefore S equal to area of OABC. It is a trapezium, therefore it is half into sum of parallel sides. AO and BC are the parallel sides. Therefore AO plus BC. Distance between parallel sides is OC. OC. Half AO is U plus BC is V. OC is time T equal to T by 2 U initial velocity plus we already know that V equal to U plus AT. So U plus AT equal to T by 2. U plus U is 2U plus AT equal to 2 get cancels, UT plus T into T square half A. Therefore, S equal to UT plus half AT square. So this is the expression for displacement in terms of time. In vector form, S equal to UT plus half AT square. These are the vectors S, U, A. Consider V equal to U plus AT, or squaring both sides we get V square equal to U plus AT whole square equal to, it is of the form A plus B whole square. So U square plus 2U AT 2AB plus B square. So it is A square T square. U square plus, I want to take 2 common factor, 2 and A, but there is no 2 here. Therefore, let us make it 2 by 2. Imagine 2 by 2. If I take 2A common factor, remaining is UT plus 2 is outside, A is outside, so half is remaining, 1A out, T square equal to U square plus 2A. If you carefully observe, UT plus half AT square, the bracket quantity is displacement S. So V square equal to U square plus 2AS. This is the final equation. In vector form, it is velocity dotted with velocity initial velocity dotted with initial velocity, because dot product of a vector with itself is square of its magnitude, plus 2 into A into S. These two are vectors. It should be dot product of two vectors. This is the vector form. What is relative velocity? Explain in the case of objects moving in the same direction and in opposite directions. Relative velocity is the velocity of a body with respect to another reference body. Velocity of a body A with respect to velocity of a body A with respect to another body B is denoted by VAB, and it is defined as VA minus VB. So this is the relative velocity. Now explain in the case of objects moving in the same direction. Suppose this is a road. This is vehicle A. This is vehicle B. Vehicle A is moving with velocity VA and vehicle B is moving with velocity VB. Velocity of A with respect to B is denoted by VAB and it is VA minus VB. So it is the difference of these two velocities. Now if they are moving in opposite directions, let this be a road. This is vehicle A. This is vehicle B. Vehicle A is moving with velocity VA. Vehicle B is moving with velocity VB, but in the opposite direction. This is positive x-axis. Velocity of A with respect to B. A with respect to B means we are in B. A is going and it is represented by VAB, no issues. It is defined as VA minus VB. Okay, VA minus VB. VA is along positive x-axis, therefore VA, this is magnitude, I am not writing vector, minus this velocity is opposite to positive x, nothing but along minus x axis, therefore take this with minus V. VA plus VB. If vehicles are moving in opposite directions, then relative velocity is sum of those two velocities. Position time graphs of two objects moving with equal velocities. Equal velocities means magnitudes and directions must be same. In position time graph, velocity is represented by positive slope. Therefore, this is velocity of one object, this is velocity of another object. If these two are parallel to each other, then it represents equal velocities. Position time graphs of two objects moving with unequal velocities, showing the time of meeting. Unequal velocities showing the time of meeting. Let this be velocity of one object. Observe positive slope. This is velocity of another object. Slope is more, means velocity is more. And here the two objects will meet. So this is the time of meet. Position time graphs of two objects with velocities in opposite directions. Opposite direction means positive slope represents one direction, negative slope represents another direction. This is velocity of first body, velocity of second. This is positive velocity and this is negative velocity. This is the time of meeting. What is uniform speed? What is non-uniform speed? So each equal to 1 mark. So this is for 2 mark question. Speed is said to be uniform if the body if the body covers equal distances in equal intervals of time. You don't have to write the diagram, but something like this. If a body covers equal distances in equal intervals of time, then it is said to be uniform. Speed is said to be non-uniform if the body covers unequal distances in equal intervals of time or equal distances in unequal intervals of time. You don't have to write the diagram. 2 meter in 1 second, 4 meter in 1 second, 0.5 meter in 1 second. Observe equal intervals of time, unequal distances. Then this is said to be non-uniform. Or 2 meter 1 second, 2 meter 4 second, next 2 meter is covered in 3 second, next 2 meter is covered in 1 second. Observe equal distances in unequal intervals of time. Then this is also said to be non-uniform. What is average speed? Mention an expression for the same. Average speed is the ratio of total distance traveled to the total time taken. Again, average speed is the ratio of total distance traveled to the total time taken. So average speed is denoted by V within angular brackets or V bar equal to total distance by total time taken. So V bar is also equal to, in terms of distances traveled along x-axis, x2 minus x1 by t2 minus t1. So delta x by delta t, or V average equal to delta r by delta t. You can write any one of these. What is uniform velocity? What is non-uniform velocity? Velocity of a body is said to be uniform if it covers equal displacements in equal intervals of time. So equal displacements in equal intervals of time. Now for non-uniform velocity. Velocity of a body is said to be non-uniform if it covers unequal displacements in equal intervals of time or equal displacements in intervals of time. Let us repeat. Velocity of a body is said to be non-uniform if it covers unequal displacements in equal intervals of time. Unequal in equal intervals of time, or equal displacements in unequal intervals of time. Define average velocity. Mention an expression for the same. Average velocity of a body is the ratio of total displacement to total time taken. Therefore, average velocity denoted by V average, use angular bracket, equal to total displacement by total time taken, or V average equal to x2 displacement minus x1 displacement by t2 minus t1, or delta x, this is displacement, by delta t, or average velocity equal to delta r by delta t. We can write any of these. Define instantaneous velocity. Mention an expression for the same. Instantaneous velocity is the velocity of a body at a given instant of time. It is defined as the limiting value of average velocity as limit delta t tends to 0. Therefore, instantaneous velocity is limit of delta s by delta t as delta t tends to 0, where delta s by delta t is called average velocity. So, limiting value of the average velocity as delta t tends to 0 is instantaneous velocity. So, this is the expression.